Hey everybody, and welcome back to the Adventures of Blink. I am of course Blink, and you can find me on GitHub right here. Now don't forget to click like and subscribe so that you won't miss any upcoming episodes. We won't miss part of the series. We're actually in the midst of season 2 here, and we're building a hangman game using a ton of DevOps tools and techniques. So today we're going to be focusing on how to handle source control. You've probably done a little bit of this already. I'd imagine that most of you probably have some experience with it in some regard, but maybe there's a few of you who haven't. And because we're going to do this in GitHub, we're going to have some additional cool stuff to play with along the way. So you might be asking yourself, why are we waiting until episode 5 to introduce source control? Shouldn't you be doing that at the beginning? You'd be absolutely right. In fact, usually when I start a project like this, I do it first by creating a repository to hold my code. And I put myself in the position of constantly using that same technique every time. I don't want to ever get away from the idea of using distributed source control. Just because it protects me in so many ways. It makes me first think about the product from the beginning, and sort of begin with the end in mind. If you've done any of like the Stephen Covey leadership stuff, you want to start with that end in mind because it'll keep things from becoming haphazard. So many code bases start as just a little thing, and then I add on another little thing, and then I add on 2 more things, and pretty soon I start having all these pieces bolted together, and I don't have any sort of rhyme or reason or organization. So forcing myself into source control right out of the gate is extremely important because it makes me stop and think about what this should look like when I'm done. The other thing it does is it stores my project in the cloud. Uh, I do trust my laptop with most things, but there are times when laptops fail, right? And if my personal device dies, I don't want to lose all the progress that I've made so far. So by pushing things regularly into GitHub, they're less likely to lose it than I am. So there we are. We're ready to get into source control today and talk about what it means to use source control in a project. The first thing we'll need to cover is just a little vocabulary. So you've probably heard the term Git, and you've heard the term GitHub, and you've heard the term GitLab, and you've probably heard of other ones. There's Atlassian's Bitbucket, for instance. There's lots of different source control tools that are out there competing for space. What's the difference? Why do we have all the different things? What are we actually accomplishing by having all the different things? So the real distinction we need to draw is primarily between the concept of Git and GitHub. Now, I'm using GitHub to collectively mean all of the other web-based tools like GitLab and Bitbucket and all those. So you have Git, the protocol, and then you have GitHub or GitLab, the tool that's available in an online platform. What's the difference between the two? Well, Git is a protocol that's developed by none other than Linus Torvalds as a way to manage distributed version control. So that's what Git is. Now the GitHub or GitLab is a product that's been built by a team that wanted to use Git as a protocol, but they wanted a centralized place to hold the repository. So Git by itself is default distributed. It goes everywhere and it can live everywhere, and you can just sort of make new connections, and it's organic in that way. GitHub provides a central place where you can say, hey, I'm going to put some authentication in front of this. So you have to log in and you have to prove your identity before you can contribute to a project. That's not part of Git by itself. So that's one of the advantages of using one of these platforms on top of the Git protocol, is that you get things like authentication. You also get extras like pull requests. So in terms of what's allowed when it comes to merging code together, in Git, you can just push things into whatever branch you want to push things into. And we'll talk about some of that later. But there are no controls over it in the Git protocol by itself. These other tools that have come along have introduced the idea of protections around those branches, where you can say, hey, we know that this is the release branch, and we don't want to push anything that's untested into that branch. We don't want anyone in the world to be able to push code into it. We want a specific subset of folks to be able to contribute on that branch. And so those kind of controls are handled at the SaaS layer, if you will, the program, the system that's built around the Git protocol. And so all of these features are wrapped up into these products. GitHub is, of course, owned by Microsoft. It was developed as its own standalone startup, and then it was acquired by Microsoft about 10 years ago, 15 years ago. Gosh, I don't even know how long. It's been a while. But GitHub is the Microsoft offering. You've also got GitLab, which is its own company. And then I mentioned Atlassian Bitbucket a minute ago. So those are kind of the big three that are in the Git space as far as these platforms go. So let's talk a little bit about how Git works as a protocol. I'm not going to go deep into the weeds with this, so this is not a primer on all the things you would ever want to know. This is sort of the basics of understanding why you would use version control in your programming experience. The Git protocol allows you to track changes to a code base using a concept called a commit. Now, a commit is going to be one or more files that are changed between point A and point B. So you start at where you are, you have your code base, and then you say, I'm going to make a change, and it's going to involve changes in this file, and that file, and this other file. And I've got 3 files that are changing. And so you would create a commit that contains those 3 file changes, and those get pushed up. Now the concept of pushing is to go between branches, because we don't want to just make the change in live code, right? We want to be able to separate the working tree from the delivery tree in a way. And so we use the concept of branches to say there's a main branch, and there are tons of strategies around this, but the general gist is that you have a main branch that is usually used as the releasable code. Like this is the current releasable situation. Like if you need to just pull the stuff in and use the software, you pull from the main branch and build it that way. However, you can create other branches. So you could create a branch for each feature, for instance. Or my personal favorite is trunk-based development, where you stay on the main branch and you pull in, if you create a separate branch, you actually just create it long enough to do whatever change you're doing, and then you merge it back in. That's a really disciplined way to handle it as a team. It's a little tough for some teams to get used to because they don't have the luxury of creating a bunch of long-lived branches. So in those cases, you're trying to keep the trunk as the latest possible version of everything, and you want it to be always in a releasable state. So that requires a tremendous amount of programmer discipline to make sure that as you make changes, they're still releasable when you're done. You never commit up a halfway finished idea. There you go in a nutshell. I'm not going to go too deep on that. I've covered some of these things before in terms of talking about being agile or delivering continuously. So if you were to look at some of the blog posts about that, I'll link them in the description here so you can find them easily. But those are concepts that we've talked about here on the Adventures of Blink along the way. Now, we're going to dig a little deeper into how some of these features in Git work. So I'm going to highlight a couple that are really important, particularly to our project. The first is the gitignore file. So you'll see this in the root of a project directory, and it's usually preceded with a dot because it's supposed to be a hidden file, but it's just .gitignore, all one word. The gitignore file is a list of patterns that you do not want Git to grab and track for you in your project. Well, didn't we just say we wanted to track all the code in our project? That doesn't make sense. Well, not everything in a project folder is part of the source code of the project. For instance, if you're writing in Java, you'll see precompiled classes every time you build the project and go through the compiling process. Uh, those compiled classes are usually with a .class extension. Um, they don't need to be submitted to source control because you already have your .java files that are your actual source. It's the code that you wrote go in those. The code that's compiled from what you wrote is put in those .classes. So you don't want to push those up. There are also things like the environment file. So, the .env that we've done in our project. We don't want that file to be pushed up to source control because it could contain things like credentials, and we don't want to put our credentials on the internet to be shared with everyone. So we're going to take a look. We'll shift over here to the screen share perspective, and we'll take a look at what it means to use a gitignore file, and we'll take a look at the example that I've built in our project. Okay, so now we're looking at our project, and you can see in our directory we've got all of our files over here. But what we're going to do is scroll down, and you see I've created a .gitignore. Let's take a look at what's inside here. Okay, so if you remember from the early episodes, I think it was episode 2 where we built the Docker container for MongoDB. One of the things we established was an external volume where Mongo would be able to store data from the database in a long-term place, so it's not part of the container and gets eliminated when the container dies. You can see here on line 2, we're blocking that folder from appearing in our Git because we don't want to push the entire database. That could ultimately become megabytes or gigabytes even of data, and we don't want all of that to be pushed up into source control. It would just be unwieldy to work with. And all of that's going to get created from scratch anyway when somebody pulls down the project for the first time and runs it. Remember, we created the script that builds the database and sets everything up on your local machine. So we don't need to include that because the automation of building the project for the first time will take care of putting that in place. A minute ago, I mentioned the env file. That's something we want to make sure is blocked from appearing in our source control, so we don't push our credentials into the internet. You'll also see a PyCache. So this is one of those things that cached built Python files create this in your directory when you're running things. You don't want to include those. .venv, the virtual environment system, we don't want to include all of that because that venv file is actually a folder, and it contains a library of all of the requirements that we've, all the dependencies that we've included in our project. We don't want those. That makes your Git repository massive really fast. And then, of course, there was a PyTest cache, which was introduced when we ran PyTest for the first time. So whatever's required to be in the cache there so that it can run, we don't want to include that. That should be built from scratch on everybody's local machine. And along the way, we'll encounter other things that probably should go in here, but currently we don't actually have any of those existing in the project. So it's something to keep in mind. You'll probably find yourself updating this file regularly. One of the really cool things about GitHub, for example, is that they'll provide a standard Python or Java gitignore file. So you can tell GitHub when you're creating the repository, I would like to include a gitignore, and it needs to be for this type of project. So the next file we're going to look at is called the README. And it's a special file as far as GitHub is concerned. I think the other platforms do it as well, but at least on GitHub, if you all caps name it readme.md, it does a really cool thing. It allows the GitHub interface to render this markdown file as a formatted web page in your project. So I'll show you a little bit of how this works. You can see the markdown syntax here. So this is how you do like a section header. And so the Adventures of Blink Season 2 Hangman, it's going to be a header section, and then it's going to be followed by a quick greeting to whoever's reading it. And then there's another section for here are the Adventures of Blink links. That's a lot to say. But you get the different links that show up there, and I can put them in a bulleted list, actually with subheadings as well, so you can do the indent on your bulleted list to get different levels. And then there's a how to use this repository. So I list out some of the things that you need to know that are in here. And we'll talk about all of this as we go through. But just to give you an idea of what this looks like, if I go over to my GitHub page, I can actually scroll down, and because README is in the root of the project, here's the rendering. And so this is what GitHub has done with it. This creates a very easy way for me as a developer to write documentation that's easy for other people to use. Okay, so the next thing we're going to look at after we've talked about the README here is the idea of branch protections. So I'm going to take you behind the scenes into the settings part of this, and we're going to look at branches, okay? Now, I have not configured branch protections on this particular repository yet, which means that I can treat this just like a standard Git repo. That means I can push code into any branch I want at any point that I want. And as long as I, don't break the merge rules as far as can this code merge with that code, I might have to resolve some conflicts there. But I can push anything into anywhere and not worry about it. This isn't necessarily ideal, particularly in a larger project, because once you release the code, you want to make sure that at least one branch is maintained, right? So if I add a branch rule set, and I'm just going to do PR to main, okay? And I'm going to set this as active. I'm not going to add anybody to the bypass list, but I am going to include my default branch. Okay, and so here are the rules that I'm going to apply. I am going to restrict creation, updates, and deletions. That means that people can still do it, but I have to give them special permission to bypass the rules. I'm going to block force pushes. That's a good one to do by default because you don't want somebody to just whack everything. The last thing I'm going to set is to require a pull request before merging. I'm not going to set any approvals because I'm the only one in the repo right now, but I do want that pull request to be in place. And I'm going to hit create. Now, that's going to require me to two-factor my way into it. So I've got to come over here and pull up my two-factor system, and I'll type in my code. And there we have it. I now have a rule on this repository that says the only way into the main branch is if I open a pull request. Now I can bypass that if I have special permission to do so, but I didn't put anybody in the bypass list, so we're not going to allow that. What this means is that if new code is created, it must be created on a branch that's not main, and it must be pushed in so that I can use a pull request to merge it. And so I'm not going to do this right now because I don't actually have anything ready to go. But each time that I do an episode, I create a separate branch in this repository so that it'll mark the progress that we made by the end of that episode. And so you can see here's this week's episode I've already pushed up. But I would create that, and you can see there's nothing to compare because I've already merged it into main. But this is the way that it works. I can select a branch and I can say I want to merge that into main, and then it would create a pull request, which is just something that happens here in the interface. that would require me to put some documentation about what's being changed. There's a place for comments field. There's a place to add rules that it will check other things. And we're going to look at that a little bit later. But it requires that pull request to exist so that I can actually push my code into main. Otherwise, I'm blocked from affecting what is my safe, healthy branch that I want to make sure is in best condition all the time. So with that in mind, the next thing we're going to look at is GitHub Actions. So the concept of GitHub Actions is to create automation that takes care of things we want to remember to do every time. For instance, last week when we wrote all that testing, technically, if I make a change to the code base, I don't have to run the tests. There's nothing that says I can't compile my code without running the tests. And so that creates a little bit of a problem for us because now I have to remember to do that every time, and that can be a little clunky. It would be better if the robot took care of that for me. And so Actions gives you a way to do this. You can write automation that you store in your repository alongside your source code that tells GitHub how to behave with your code. So let's take a look at how we get these GitHub Actions to work. First, I'm going to go over to the source code. Now, in order to create a GitHub Actions workflow, you want to create a .github folder in the root of your project. And inside of that, you want a workflows folder. So you can see I've got that in there, and I've only got one file right now, the pytest.yaml. GitHub Actions are written in YAML. It's a simple language to be able to mark up what you're doing, to give it an easy way for the computer to understand your code. It requires you to learn some things about what tags are available to you and things like that. And I'm not going to go deep down that rabbit hole, but I thought I'd walk you through a simple PyTest YAML for GitHub Actions to use. So the on statement here on line 2 specifies that we're talking right now in this block about when the workflow will be executed by GitHub. And so we've said it needs to happen on push, when code is pushed to a certain repository. And we're going to be specific and say on branches. So now you see we're on push branches. Okay? Now, this means that only the branches that match these filters will allow this code to run. The automation won't kick off unless it is covered by these filters. So the only thing that we're saying here is don't run it on main. What we've actually specified here is we want every branch except main to be able to run. So these are wildcards, and that means every branch in our repository except for the one named main is going to require this workflow to run when you push to it. So the next thing we have to do is say what kinds of code are allowed to cause this to run. So we handled the branches, but we don't want to change it every time, because if I'm changing the database, there's no reason for me to rerun my unit tests on the front end. So I'm making it so that only things in the Hangman folder that are named .py, my Python files. And the other thing I want to do is make it so that if I change this workflow, it will cause it to rerun on the next push as well. That way I can test it easily. So those are the two settings I put in there. There's a paths section, and then you add those two paths in, and that takes care of it. Now, using everything under on, our project knows when to run things within GitHub. Now, the next thing we're going to look at here is jobs. So in this YAML, you'll find that jobs are the list of instructions that we want it to do. You can group them together in steps that explain the different parts of doing each job. So you can create a list of steps, and then you can create multiple jobs in here as well. The reason you would do that is if you wanted to be able to run things in parallel, or if you had a set of steps that couldn't happen until something happened before them, stuff like that. So in this, we only have one job. It's the front-end unit test. And so we're saying that it runs on an Ubuntu latest image. So you can think of this as running in containers within GitHub. There are Docker container-ish things that live inside the GitHub environment, and Ubuntu latest tells you what kind of platform is running in that container. The strategy we're going to use is we want Python version 3.12 for everything we're doing, and that matches with the version of Python that I've got loaded on my laptop, and so that way I know I'm running the same code, and I can maintain that. I can decide that this is a Python 3.12 app and not allow it to upgrade beyond that. Now let's talk about the steps. So you've got a checkout. This is getting your code out of GitHub and setting up Python. So now let's talk about the steps. First, you have to say that steps are going to use certain pre-built capabilities within the GitHub Actions framework. So actions/checkout v4 says that we're using the git checkout that GitHub provides as part of that. And they're on version 4, so that's the one that I'm using currently. The next thing we look at is the next step is going to be set up Python. And so we're using a GitHub provided action runner there that does set up Python. And so the only thing we're passing it is that we want a certain version of Python. So we put our 3.12 in there as well. The next step is to install the dependencies. So you've probably done this from your command line, but you come in here to the run and you can pass in, this is effectively like writing a bash script within the run block. So the run block allows you to run, bash commands as if you were on that Ubuntu Linux box. So we do a pip install with all of our requirements, and then we do a pip install of PyTest. And once that's finished, we're ready to actually run PyTest. And so this is nice and convenient and short, that the only thing you have to do to run PyTest is type PyTest. And so that's how you get started. Now, when we save this file, there's one thing we have to keep in mind, and that's that we're going to be pushing this code all the way to main before anything will operate. So when you create an action for the first time, you have to push it all the way to main before GitHub will allow it to operate. Once you've gone beyond there, it starts following the rules that were back up here at the top in the on block. So that's a little weird quirk that you have to pay attention to. The first time you build it, if the YAML doesn't exist in main, it's not going to trigger GitHub Actions. Once the YAML exists in main, it will start following the rules that are in the on block. So we'll go back over to GitHub and we can see what happened here. So the first time I ran this, I made a comment change, and so that's picking up my commit message to say this is what was going on at that point. And when I ran this, I'll show you why it failed. So you can go in here and you can see process completed with exit code 1. Something didn't go right. So I can pop in here, and on install dependencies, I still had my upgrade pip command in there, and I didn't format it right. So I just took it out. It wasn't critically important to the process. It's a nice to have rather than a need to have. So I took that out and fixed the mistake in my action workflow was the next commit message. And when I pushed this code up, I actually got a job completed. And so you can see here, it ran through all the steps. In GitHub Actions, you get the ability to actually open up, so the install dependencies, pip install our hangman requirements. It shows you all the things that happened in there. You're getting your console output in the same way that you would if you ran this on your local console. And then there's the run PyTest. And so you can see it ran the PyTest and 7 tests passed. So if I got a failure here, it would actually fail this action from running. And this would be a red X instead of a green check mark. And that would happen for problems with the way the code is set up, as well as problems with the tests actually succeeding. And so if a test fails, it stops the build. And that means that then I would have to come in here and go figure out what was wrong with it and fix that and rerun. So as we've backed up here, we can now see all those things are up. The last thing that we could talk about here is the ability, and I'll shift back over here to the code. We can actually put a statement in the on block that says, do this on pull requests. This is extremely valuable because then you can require a pull request to have a passed test before it's allowed to be merged. So I can show you a little bit of that history. If I go to my pull request history here, I'll look at the closed, and here's the last one. You see it's got a little green check next to it. So when I created this pull request to merge episode 5's code into main, I didn't actually provide a description. Bad bin. I should have done better at that. But then you can see down here, there's one check passed on this merge commit. And you can see the X appears to say, hey, there was a problem with this, and the check appears to say, hey, it was resolved at that point. So I can go to the view details and it will show me, here's the check that passed. And I can even go dig into the details just like that. So that's the value of using GitHub Actions, because now I don't have to think about it anymore. I don't have to go, oh, did I remember to run my tests this time? No, I know that when the code gets pushed into GitHub, it's going to take care of it for me. So there you have it. This is how you use GitHub Actions to make you a more effective developer. You offload all these little things that you have to remember to do and make them into automations and build them right into the workflow. This is the way that the DevOps tools accelerate development processes, by doing extra work for you and just bringing those things to the table so that as you're trying to merge your code, all those tests are taken care of automatically. You don't have to remember the steps. You don't even have to know how all the steps work. You could offload things to someone else's tool, and if they give you a thumbs up, then you're good to go. So any of these kind of things that you could theoretically build into the process manually, you should think about using something like Actions as a way to maintain that. So that concludes another episode of the Adventures of Blink. I am so glad you joined me today, and I can't wait to see what you build. See you next time.